Now we're at the last part of this chapter, Newton's third law. And we write this as N3L. So note, you can do many of the problems on the homework now, okay? So now we're just going to focus on Newton's third law, which is a very short law that we're going to talk about. I won't finish it today, but I'll finish it very early on Monday. So what does this tell us here? This law tells us how objects interact with each other. How do they interact? And what I'll do here is that I'll start off with some example so you can get a sense of what I'm talking about. And what I'm going to do in this example here is that I'm going to come in and I'm going to push a water bottle with my hand. So if I look at this thing, here's what I'm seeing here. What I'm seeing here is that I have my ground right here. And then I have my water bottle. So I imagine that here's my bottle. And of course, because this is a water bottle, it has to have water in it. So what I'm seeing here is that now my hand is going to come in. Oops, wrong. So my hand comes in, and then I'm going to apply a force on it. So when I'm looking at my hand, what I'm seeing here is it's going to apply a force due to my hand here. Now so I want to talk about the interaction between my hand and the bottle. So what do I know here? There are two interacting objects. What are those two things? Well, one has to be my hand, and the other one has to be the water bottle. Okay? And so what's really hard to kind of comprehend is that there's only one interaction between these two objects. And what I mean here is that when I touch the water bottle with my hand, at the same time, the water bottle is touching my hand. So what I mean by that in this language, what I would say here is that any contact between two objects, in this case, it's going to be my hand and the bottle, requires a single interaction. Right? When I touch the water bottle, because I'm so close to the edge, I'm just going to move this over just a tiny bit. Because when I touch the water bottle, do I have to wait before the water bottle touches me back? Well, no. As soon as I touch the water bottle is touching me. That's what I mean by it's a single interaction. And then we say that this single interaction requires not one force, but two forces. In this case, it's got to be the two forces are going to be what here? So if I look at this scenario here, what we say here is that this is the force of my hand on the bottle versus the force of the bottle on my hand. There are two different forces because it's a single interaction. So now, what does Newton's third law have to say about those forces? So here we go. Newton's third law, N3L. And here's what it says. This is sometimes known as the action-reaction law. And it says this: whenever one object exerts a force on a second object. So picture-wise, what do I mean by that? What I mean by that, imagine that we have two blocks that are coming at each other. So what I'm going to do here is that I'm going to draw a red block. So let's say this is the red block. And what I know about the red block here is that it's moving in this direction. And I'm going to call that block 1. Then I have a second block. It's moving in this direction, in the opposite direction. So when I look at this guy, I'm going to call this block 2. And of course, they're sliding across the surface. Now, that's what I mean. They're going to interact. These two objects are going to interact. So whenever one force acts on the other one, so now these blocks collide. So when I look at this picture here, there's this block. There's the second block. So now they have collided here. So now we have 1, we have 2, and they're interacting now. So now what we say here is we have interacting blocks. So here's what you find here. It goes like this. Newton's third law says the second object exerts an equal and opposite force. This is remarkable. So it says this. So when the block 1, when it interacts with block 2, we know that that red block is going to apply a force of 1 on 2. Now, action and reaction are arbitrary words here. And you know what? I'm going to move this over a little bit because I'm going to run into space issues. So in this case, I'm going to say that this first block is the action. Now remember, action and reaction are arbitrary. Newton's third law says that now there is an equal and opposite force. This will be force 2 on 1. And this is known as the reaction. So Newton's third law reads exactly like this. It says that the force of 1 on 2 is equal in strength to the force of 2 on 1. But because they are opposite, we then come in here and we say, there's a minus sign. And the minus sign tells us that they're opposite in direction. That is Newton's third law. And this law is so damn counterintuitive, it's crazy. It is literally crazy how counterintuitive this law is. And even I get tricked by this law from time to time.